Have you ever had that moment where you're walking through the woods at night and every shadow seems to hold something sinister? That feeling where your brain starts conjuring up all the worst possible creatures that could be lurking just beyond your vision? Well, here's the thing about that primal fear we all carry deep in our bones. It's not just paranoia. Our ancestors actually lived alongside monsters that would make your worst nightmares look like bedtime stories. Picture this. You're stepping out of your cave one morning, maybe 50,000 years ago, just trying to gather some berries for breakfast. But instead of worrying about bears or wolves, you've got to keep an eye out for birds the size of pickup trucks with beaks that could crack your skull like an eggshell. Or maybe you decide to take a refreshing swim in the local river, not knowing that lurking beneath the surface is a snake so massive it could swallow you whole without even pausing to chew. The truth is, our planet used to be home to creatures so terrifying, so absolutely nightmarish, that extinction might have been the best thing that ever happened to humanity. We're talking about animals that were built like living weapons, designed by nature to be the ultimate killing machines. These weren't just bigger versions of animals we know today. These were evolutionary experiments gone absolutely wild. Now, I know what you're thinking. Extinction is usually something we mourn, right? We talk about saving endangered species, preserving biodiversity, protecting the delicate balance of nature. And you're absolutely correct. Extinction is generally a tragedy. But sometimes, just sometimes, Mother Nature makes a decision that benefits everyone involved. Today, we're going to explore those times when extinction was less of a loss and more of a cosmic favor to every living thing on this planet. What makes this even more fascinating is that some of these creatures didn't vanish millions of years before humans evolved. Some of them were around when our ancestors were just figuring out how to make fire and craft simple tools. Can you imagine trying to establish the first human settlements while massive predators the size of school buses were roaming around looking for their next meal? Our species might never have made it past the Stone Age. But here's where it gets really wild. We're not just talking about creatures that lived on land. The oceans were filled with monsters that would make today's great white sharks look like goldfish. The skies were dominated by flying predators with the wingspans that could cast shadows over entire villages. Even the insects were getting in on the action, growing to sizes that would send you running for the nearest can of industrial-strength bug spray. The thing about these ancient beasts is that they weren't just randomly huge and scary. Evolution had crafted them with surgical precision to be perfect killing machines. We're talking about animals with teeth designed like surgical instruments, jaws that could snap shut with the force of hydraulic presses, and hunting strategies that would make modern military tacticians jealous. Some of these creatures were so well adapted to their environments that they dominated their ecosystems for millions of years. They were the undisputed champions of their domains, the apex predators that everything else either fled from or became dinner for. And yet, despite their incredible success, they all eventually met their match with changing climates, shifting continents, or in some cases, the rise of humanity itself. What's truly mind-boggling is how different our world would be today if even just a few of these species had survived. Imagine trying to build cities when you have to account for massive aerial predators that could snatch people right off the streets. Think about how different ocean travel would be if we had to navigate around sea monsters that could sink ships just by surfacing for air. The stories of these creatures read like something out of a fantasy novel, except they're all completely real. Scientists have pieced together their existence from fossilized remains, bite marks left in other fossils, and sometimes even preserved specimens that give us incredibly detailed looks at what these animals were actually like. And trust me, the reality is often more terrifying than any fiction writer could dream of. But before we dive into our countdown of these prehistoric nightmares, let me paint you a picture of what life might have been like if they were still around. Imagine waking up tomorrow morning and checking the weather app, but instead of just temperature and precipitation, you also had to check the daily predator migration patterns. Picture trying to plan a beach vacation while factoring in the feeding schedules of bus-sized sharks. Think about how different camping would be if you had to worry about flying reptiles with wingspans wider than airplane wings swooping down to investigate your campfire. The more you learn about these extinct creatures, the more you realize that their disappearance wasn't just lucky for humans, it was essential for the development of complex civilization as we know it. These animals were so dominant, so perfectly adapted for hunting and killing, that they would have kept most other species, including our own ancestors, in a constant state of survival mode. Now, I should mention that not all of these creatures were necessarily evil or malicious. Many of them were just following their natural instincts, doing what evolution had programmed them to do. They were filling ecological niches, maintaining balance in their ecosystems, and simply trying to survive just like every other living thing. But from our perspective as relatively small, relatively defenseless primates, these animals represented existential threats on a scale that's hard to comprehend. What makes studying these extinct predators so fascinating is that each one tells a story about a completely different world. Some lived in oceans that covered areas that are now dry land. Others thrived in climates that were drastically different from what we see today. Each species gives us a window into an alien version of Earth, a planet where the rules of survival were written by creatures that could crush modern apex predators without breaking a sweat. As we count down from 24 to number 1, you're going to see a pattern emerge. These weren't just animals that happened to be big and scary. They were evolutionary masterpieces of destruction. Nature had taken millions of years to craft each one into the perfect killing machine for its particular environment and time period. They had specialized hunting techniques, unique anatomical features, and survival strategies that allowed them to dominate their ecosystems completely. Some of these creatures lived in the ocean depths, turning the seas into hunting grounds where nothing was safe. Others ruled the skies, making flight a luxury that came with deadly risks, and some controlled the land with such authority that entire food chains were built around avoiding them. What's really going to surprise you is how recently some of these animals were still around. We're not always talking about creatures that vanished with the dinosaurs. Some of these nightmare-inducing beasts were sharing the planet with early human civilizations. Our ancestors had to develop tools, strategies, and entire ways of life, while these monsters were still very much a part of the world. The fossil record tells us incredible stories about encounters between early humans and some of these creatures. We can see evidence of desperate battles, narrow escapes, and the gradual development of human ingenuity in response to these overwhelming threats. In many ways, these extinct predators shaped human evolution just as much as we eventually contributed to their extinction. Each creature on our list represents a different kind of terror. Some were built for stealth, ambushing their prey with lightning-fast attacks that left no chance for escape. Others relied on brute force, using massive size and overwhelming power to dominate everything in their path. And some were tactical hunters, using intelligence and coordination to take down prey much larger than themselves. The variety of hunting strategies these creatures employed is absolutely staggering. We're talking about animals that could hunt in packs, coordinate complex attacks, and even use tools in some cases. These weren't mindless eating machines. They were sophisticated predators with behavioral complexity that would impress modern wildlife researchers. But perhaps most unsettling of all is how perfectly adapted these creatures were to killing. Evolution had spent countless generations refining their hunting abilities, sharpening their weapons, and improving their success rates. They were the end result of nature's longest and most intensive arms race. And they were winning decisively. So buckle up, because we're about to take a journey through prehistoric horror that will make you grateful for every day you get to live in a world where the most dangerous thing you might encounter on a nature walk is an angry bee, or maybe a territorial goose. These 24 creatures represent some of the most successful killers in the history of life on Earth. And their extinction stories are going to leave you with a whole new appreciation for the relatively peaceful world we inhabit today. From massive land predators that could chase down prey at highway speeds to flying hunters that could spot victims from miles away. From ocean monsters that turned the seas into death traps to insect swarms that could strip flesh from bone in minutes. We've got it all. And trust me, by the time we reach number 1 on this list, you're going to understand exactly why sometimes extinction is actually the best possible outcome for everyone involved. Let's start with number 24. And trust me, this one sets the tone perfectly for what we're dealing with here. Meet the Smilodon, though you probably know it better by its more intimidating nickname, the saber-toothed cat. Now, when I say saber-toothed, I'm not talking about some house cat with slightly pointy teeth. We're talking about a predator that evolution decided needed daggers for canines. These weren't your average big cats. The Smilodon was built like a furry tank with a jaw that could unhinge wider than any modern feline. Those famous teeth weren't just for show either. They were precision instruments designed for one purpose: ending lives as efficiently as possible. Picture a mountain lion, but then imagine someone decided it needed to be more muscular, more aggressive, and equipped with twin sabers sticking out of its mouth. That's what our ancestors had to worry about during their evening strolls. The really unsettling part about saber-toothed cats is how they hunted. These weren't chase predators like modern big cats. They were ambush specialists, hiding in wait until some unfortunate creature wandered too close. Then it was game over in seconds. Those massive canines would pierce vital areas with surgical precision, and their incredibly strong neck muscles would drive those teeth deep enough to hit all the important stuff. No long struggle, no dramatic chase scene, just lights out. What makes this even more terrifying is that early humans almost certainly shared hunting grounds with these beasts. Archaeological evidence suggests that our ancestors and saber-toothed cats were competing for the same prey in the same areas. Can you imagine trying to hunt mammoths when you have to constantly watch over your shoulder for a predator that could take you down before you even knew it was there? Moving on to number 23, and this is where things get properly nightmarish. Say hello to Pentacopterus decorohensis, which sounds like a scientific name until you realize what it actually describes. A scorpion the size of a canoe. We're talking about an aquatic nightmare that measured nearly 5 feet from head to tail, swimming around ancient seas like some kind of underwater demon. Now, scorpions today are already pretty high on most people's list of creatures they'd rather not encounter. But imagine scaling that up to the size of a large dog, giving it the ability to swim faster than you could ever hope to escape, and then setting it loose in waters where you might want to go fishing or take a refreshing dip. This thing wasn't just big. It was perfectly designed for aquatic hunting, with powerful swimming appendages and all the predatory instincts of its smaller modern relatives. The fossil evidence suggests these creatures were apex predators in their marine environments. They had the size advantage over most everything else in the water, plus all the natural weaponry that makes modern scorpions so effective. Their claws were powerful enough to grab and hold struggling prey, while their stinger could deliver whatever toxic cocktail they'd evolved to subdue their victims. What's particularly unsettling about Pentacopterus is how it represents a world where even the water wasn't safe. Today, when we think about dangerous aquatic life, we worry about sharks or maybe some aggressive fish. But imagine trying to cross a river knowing that something the size of a coffee table with pincers and a venomous stinker might be lurking just beneath the surface. Number 22 takes us into truly bizarre territory with something called hallucigenia. The name alone should tell you this creature was the stuff of nightmares, but the reality is somehow worse than anything your imagination could conjure up. Picture a worm-like creature, but then imagine someone decided it needed legs, or maybe tentacles, because scientists still aren't entirely sure what those appendages actually were. This thing looked like it was designed by someone having a fever dream about the worst possible creature they could imagine. It had rows of spines running along one side of its body, presumably for defense, and then these flexible, tube-like appendages on the other side that might have been legs, might have been feeding tentacles, and might have had mouths on them. Yes, you heard that right. Mouths on its legs. The fossil record for hallucigenia is frustrating because it's so unlike anything that exists today that scientists have had to completely reconstruct how it might have lived and moved. What we do know is that it was a successful design for its time period, which means there were probably lots of these nightmare worms crawling around ancient sea floors, doing whatever it is that creatures with spiny backs and tentacle legs do. The truly disturbing part about hallucigenia is how it challenges our basic understanding of what animals should look like. We're used to creatures having a clear head, a clear tail, obvious legs, and recognizable body parts. This thing was like nature decided to throw all those rules out the window and create something that would haunt the dreams of paleontologists centuries later. Number 21 brings us to Gigantopithecus, and this is where the Bigfoot legends start making a lot more sense. Imagine an ape that stood nearly 10 feet tall with an arm span that could reach 12 feet. We're talking about a primate that could have looked down at professional basketball players and considered them vertically challenged. Now, the good news is that Gigantopithecus was probably vegetarian. The bad news is that when something weighs as much as a small car and has arms longer than most people are tall, its dietary preferences don't really matter if it decides you're bothering it. Even the most peaceful giant ape could accidentally crush you just by giving you what it considers a friendly pat on the back. These massive primates lived in Asia until relatively recently in evolutionary terms. We're talking about maybe 1,000 years ago. That means they were sharing the planet with early human civilizations. Imagine being an ancient trader traveling through the forests of Asia and coming face to face with what essentially amounts to King Kong's slightly smaller cousin. The fossil evidence suggests that Gigantopithecus was indeed peaceful, probably spending most of its time foraging for plants and fruits in the forest canopy. But here's the thing about creatures that size. They don't need to be aggressive to be dangerous. Their sheer mass and strength would make any encounter potentially fatal for smaller creatures like humans. What's really fascinating about Gigantopithecus is how it represents the extreme end of primate evolution. Modern great apes are already impressively strong and large, but this species took those traits and amplified them to almost mythical proportions. It's no wonder that cultures across Asia developed legends about giant forest creatures. They were probably based on real encounters with these massive apes. Moving to number 20, we encounter Harpagornis moray, better known as Haast's eagle. This is where we learn that sometimes the most terrifying predators come from the sky. Picture an eagle with a wingspan that could cast shadows over entire groups of people, with talons designed specifically for grabbing prey much larger than anything modern eagles would dare to attack. Haast's eagle lived in New Zealand until about 500 years ago, which means it was around when the first Polynesian settlers arrived. And here's the truly terrifying part. Local Maori legends specifically mention giant birds that could swoop down and carry off children. These weren't mythical stories. They were historical accounts of actual encounters with flying predators that were perfectly capable of treating humans as prey. These eagles developed what scientists call island gigantism, growing to enormous sizes because they had no competition in their ecosystem. They were the undisputed rulers of New Zealand's skies, and everything else on the islands had to live with the constant threat of death from above. Their hunting strategy was simple but effective. Spot prey from high altitude, dive down at incredible speeds, and use their massive talons to grab victims before they even knew what was happening. The extinction of Haast's eagle is actually a relatively recent event in evolutionary terms. When the early Polynesian settlers arrived in New Zealand, they began hunting the large flightless birds that the eagles depended on for food. As their primary prey species disappeared, so did the eagles. It's one of the few cases where human activity led to the extinction of an apex predator. And honestly, it was probably for the best. Imagine trying to explain to someone today that you can't go swimming because the local river is home to sharks with spiral-shaped mouths full of rotating teeth. They'd probably think you lost your mind, but that's exactly the kind of world our ancestors navigated. Number 19 on our list is a creature so bizarre that scientists spent decades trying to figure out how its mouth even worked. Meet Helicoprion, also known as the buzzsaw shark. Now, when I say buzzsaw, I'm not being metaphorical here. This thing literally had a mouth that looked like someone had taken a circular saw blade and decided it would make perfect shark teeth. The really disturbing part is that unlike modern sharks that shed their old teeth, Helicoprion just kept growing new ones, pushing the older teeth forward into this horrifying spiral of death. Picture this nightmare fuel swimming toward you in ancient seas. As new teeth grew in the back of its mouth, they would push the existing teeth forward and outward, creating what can only be described as a living wood chipper. Scientists are still debating exactly how this mechanism worked, but the fossil evidence is clear. This shark had found a way to turn its entire mouth into a rotating blade of destruction. The really unsettling part is that we still don't have complete skeletons of these creatures, which means our understanding of just how terrifying they were is probably incomplete. What we do know is that they were successful enough to survive for millions of years, which suggests that having a buzzsaw for a mouth was actually an effective hunting strategy in prehistoric oceans. Can you imagine being an ancient fisherman and having one of these things surface near your boat? The psychological trauma alone would probably end your maritime career permanently. These weren't just sharks with weird teeth. They were evolutionary experiments in creative killing that somehow worked well enough to dominate their aquatic ecosystems. Number 18 brings us to something that'll make you never complain about city rats again. Joseph Artegasia monesi was basically what would happen if someone decided regular rats needed to be the size of small cars. We're talking about rodents that could grow to 10 feet in length with 5-foot tails, weighing as much as a small horse. Now, the somewhat comforting news is that these giant rats were probably herbivores. The absolutely terrifying news is that they had foot-long incisors that could grow continuously throughout their lives. Imagine encountering something the size of a bull with the gnawing instincts of a rat and teeth that never stopped growing. Even if it wasn't trying to eat you, those constantly growing teeth needed to be worn down somehow, and you definitely didn't want to be what it decided to chew on. These massive rodents lived in South America about 8 million years ago, inhabiting river deltas and wetland areas. The fossil evidence suggests they were social animals, which means they probably lived in groups. Picture stumbling upon a colony of car-sized rats, all busily gnawing on trees with their foot-long teeth. It's the kind of scene that would send even the most experienced wildlife researcher running for the nearest exit. What makes Joseph Artegacia particularly unsettling is how it represents the extreme end of rodent evolution. Modern rodents are already remarkably successful at surviving and reproducing, but these ancient giants took those traits and scaled them up to absolutely massive proportions. They were essentially living proof that sometimes evolution decides to take successful designs and make them terrifyingly large. The extinction of these giant rats probably had a lot to do with changing climate conditions and shifting ecosystems. As their wetland habitats dried up and changed, these massive creatures couldn't adapt quickly enough to survive, which is probably for the best, because imagine trying to rodent-proof your house when the local rats are the size of motorcycles. Moving on to number 17, we encounter something that makes the Loch Ness Monster look like a friendly pool noodle. Titanoboa was exactly what its name suggests, a titanic snake that redefined everything we thought we knew about how large serpents could grow. Picture a snake that could reach 42 feet in length and weigh as much as a small car, capable of swallowing prey whole without even bothering to constrict it first. This wasn't just a bigger version of snakes we know today. Titanoboa was an evolutionary masterpiece of efficient killing, perfectly adapted for life in the hot, humid swamps of ancient South America. Its sheer size meant that almost nothing in its environment was safe. It could hunt in water or on land, and its thermal regulation was so efficient that it could remain active even in extreme heat that would incapacitate smaller predators. The really terrifying aspect of Titanoboa is how it hunted. Modern large constrictors like pythons and anacondas wrap around their prey and squeeze until circulation stops. Titanoboa was so massive that it could simply grab prey in its jaws and swallow it alive. We're talking about a predator that could treat crocodiles like appetizers and consider early mammals barely worth the effort of a proper meal. Fossil evidence suggests that Titanoboa lived about 60 million years ago, which means it never encountered humans directly. But imagine if it had survived to modern times. River travel in South America would be absolutely impossible, and entire ecosystems would be organized around avoiding areas where these giant serpents might be lurking. Even today's largest anacondas would look like earthworms compared to these prehistoric monsters. What's particularly fascinating about Titanoboa is how its existence tells us about ancient climate conditions. Snakes are cold-blooded, which means their maximum size is limited by environmental temperature. For Titanoboa to reach such massive proportions, the ancient world must have been significantly hotter than today's climate. It was a living thermometer that measured prehistoric heat levels. By growing to absolutely enormous size, number 16 takes us into the realm of insects, and trust me, this is where things get properly nightmarish. Meganura was essentially a dragonfly that someone had decided needed to be the size of a small bird. We're talking about flying insects with wingspans that could reach over 2 feet, equipped with the hunting instincts of modern dragonflies, but scaled up to absolutely terrifying proportions. Now, modern dragonflies are already impressive predators in the insect world. They have incredible eyesight, lightning-fast reflexes, and flight capabilities that put most other flying creatures to shame. But imagine encountering one that's large enough to actually pose a physical threat to humans. These weren't just big bugs. They were aerial predators that could hunt small vertebrates and probably considered anything smaller than themselves to be potential prey. The really unsettling part about Meganura is how it represents a time when insects ruled the skies. Before birds evolved, before flying reptiles became common, giant insects dominated aerial ecosystems. They were the undisputed masters of three-dimensional hunting, capable of pursuing prey through complex flight patterns that would challenge even modern military pilots. These giant dragonflies lived during a time when atmospheric oxygen levels were much higher than today, which allowed insects to grow to sizes that would be impossible in our current environment. Higher oxygen concentration meant more efficient metabolism, which translated directly into larger body sizes. It was like nature had decided to give insects performance-enhancing drugs and see how big they could get. The extinction of Meganura probably had a lot to do with changing atmospheric conditions and the evolution of more efficient flying predators like birds and bats. But imagine if they had survived to modern times. Outdoor activities would require completely different safety considerations, and the phrase swatting flies would take on a whole new meaning when the flies are large enough to swat back. Number 15 brings us back to aquatic nightmares with Dunkleosteus, a fish that evolution decided needed to be armored like a tank and equipped with a mouth designed for crushing through bone. This wasn't just a big fish. It was a 30-foot-long killing machine that dominated ancient seas with the efficiency of a military submarine. The most terrifying aspect of Dunkleosteus wasn't its size, though 30 feet of predatory fish is certainly intimidating enough. It was the jaw mechanism that evolution had crafted for maximum destructive potential. Instead of teeth, this creature had bony plates that functioned like massive shears, capable of slicing through the armor of other prehistoric marine creatures with surgical precision. Scientists have calculated that Dunkleosteus could snap its jaws shut with a bite force that exceeded most land predators, including tyrannosaurs. We're talking about hydraulic-level pressure concentrated into bone-cutting edges that could probably bite through steel, if steel had existed back then. The speed of its bite was equally impressive. It could go from mouth open to bone-crushing closure in just milliseconds. What makes Dunkleosteus particularly unsettling is evidence suggesting it was cannibalistic. Fossil remains show bite marks from other Dunkleosteus, which means these armored nightmares were perfectly willing to hunt and eat their own species. In a world where even the apex predators weren't safe from each other, smaller creatures like early vertebrates had essentially no chance of survival in open water. The extinction of Dunkleosteus probably resulted from changing ocean conditions and the evolution of more efficient predators. But imagine if they had survived to modern times. Commercial fishing would be impossible in many areas, and naval warfare would have to account for the possibility of 30-foot armored fish attacking ships. Even today's great white sharks would probably avoid areas where these creatures were known to hunt. Number 14 takes us to something that challenges our basic understanding of what apex predators should look like. Anomalocaris was essentially a giant shrimp that decided it wanted to be the ocean's ultimate killing machine. At 6 feet in length, it was enormous for its time period, and it had evolved some truly creative solutions for catching and eating prey. The most distinctive feature of Anomalocaris was its pair of flexible appendages that extended from the front of its body like massive tentacles. But these weren't just for show. They were lined with sharp spines and could grab prey with incredible precision. Imagine a creature that could reach out with tentacle arms, grab you with surgical accuracy, and then drag you toward a mouth that was perfectly designed for processing struggling victims. What's particularly fascinating about Anomalocaris is how it represents one of the earliest examples of complex predatory behavior in Earth's oceans. This creature wasn't just randomly attacking whatever came near. It was actively hunting, using sophisticated techniques to locate, capture, and consume prey. It was like nature's first experiment in creating an intelligent marine predator. The fossil evidence suggests that Anomalocaris was incredibly successful in its ecological niche, dominating Cambrian seas for millions of years. It was the undisputed apex predator of its time, and everything else in the ocean had to evolve strategies for avoiding those grasping tentacle arms and that circular tooth-lined mouth. The extinction of Anomalocaris probably resulted from changing ocean chemistry and the evolution of more efficient predators, but its legacy lives on in the form of modern arthropods. Every time you see a lobster or a crab, you're looking at a distant relative of this ancient nightmare. Fortunately, modern crustaceans decided to focus on scavenging rather than active predation on the scale of their prehistoric ancestors. Number 13 introduces us to Titanocorax, a creature that shows us just how terrifying the ancient world could be, even at a relatively small scale. At 1/2 meter in length, this thing might not sound particularly intimidating until you realize that during the Cambrian period, most marine life was barely larger than your thumb. Titanocorax was essentially the Godzilla of its time, a massive predator in a world of tiny creatures. What made this ancient arthropod particularly nightmarish was its complete package of predatory features. We're talking about a creature with a mouth lined with sharp teeth, powerful claws designed for grabbing struggling prey, and body flaps that made it an incredibly efficient swimmer. It was like evolution had taken everything scary about modern marine predators and compressed it all into one terrifying package. The really unsettling aspect of Titanocorax is how it dominated its environment through sheer size advantage. In a world where most creatures were microscopic, being 1/2 meter long made you essentially invincible. Everything else in the ocean was potential prey, and this thing had the equipment to catch and process whatever it wanted to eat. Imagine snorkeling in ancient seas and encountering something like this. Today, We worry about jellyfish stings or maybe some aggressive fish. But back then, you'd have to deal with arthropod monsters that were perfectly designed for hunting anything smaller than themselves. And since almost everything was smaller than them, that meant pretty much the entire ecosystem was on the menu. The fossil record shows that Titanocorax was incredibly successful for its time period, which means these underwater nightmares were probably common sights in Cambrian oceans. They represent a time when the rules of predation were being written by creatures that looked like they'd been designed by someone having fever dreams about the worst possible sea monsters. Moving on to number 12, we encounter something that makes modern ostriches look like harmless pet birds. Meet the terror bird. And trust me, that name is not an exaggeration. These flightless predators could grow to 10 feet in height and were equipped with beaks so powerful they could crack skulls with a single strike. Picture a bird the size of a small dinosaur with the attitude of a honey badger and weapons that would make medieval knights jealous. Terror birds dominated South American landscapes for millions of years, and they earned their fearsome reputation through sheer efficiency. These weren't scavengers hoping to find leftover meals. They were active hunters that could chase down prey at speeds that would challenge modern racehorses. Their long legs were built for pursuit, and once they caught up to their target, that massive beak would end the chase permanently. What makes terror birds particularly terrifying is how they represent the evolution of flightless predators that were perfectly adapted for ground-based hunting. They didn't need to fly because nothing on the ground could escape them anyway. Their hunting strategy was simple but devastatingly effective. Run down prey using superior speed and endurance, then deliver a killing blow with that bone-crushing beak. The fossil evidence suggests that terror birds were the apex predators of their ecosystems, sitting at the top of food chains that included some pretty impressive herbivores. They were taking down prey that modern big cats would think twice about attacking, and they were doing it with nothing more than speed, power, and that incredible beak. These prehistoric nightmares survived until relatively recently in evolutionary terms, with some species possibly lasting until just a few thousand years ago in remote parts of South America. Early human settlers in the region might have actually encountered these creatures, which would explain some of the more terrifying bird-related legends in South American cultures. Number 11 takes us back to the skies with Argentavis, a prehistoric vulture that redefined everything we thought we knew about how large flying birds could get. With a wingspan of 20 feet and the body mass of a small airplane, this thing wasn't just a bird. It was a flying fortress equipped with all the predatory instincts of modern raptors, but scaled up to absolutely massive proportions. The really impressive thing about Argentavis is that it was actually capable of powered flight despite its enormous size. Modern physics tells us there are limits to how large flying creatures can get. But somehow, this prehistoric giant managed to stay airborne while maintaining the ability to hunt effectively from the sky. It was like nature had decided to ignore the laws of aerodynamics and create a flying predator that could dominate both land and sky. What made Argentavis particularly formidable was its hunting strategy. Unlike modern vultures that primarily scavenge, this massive bird was an active predator that could spot prey from incredible distances and then swoop down at speeds that would make modern fighter jets jealous. Its talons were large enough to grab prey the size of small deer, and its beak was perfectly designed for processing large meals efficiently. The fossil evidence suggests that Argentavis spent most of its time soaring over open grasslands, using thermal currents to stay aloft while scanning for potential prey. When it spotted something interesting, it could dive from altitudes that would give it enormous kinetic energy, essentially turning itself into a guided missile with claws. Imagine trying to cross open plains, knowing that something the size of a small aircraft might be circling overhead, just waiting for the right moment to dive down and grab you. Argentavis represents a time when the sky itself was a hunting ground, and anything moving in open areas had to constantly watch for shadows that might indicate incoming death from above. The extinction of Argentavis probably resulted from changing climate conditions and the disappearance of the large prey species it depended on. But if it had survived to modern times, air travel would be significantly more complicated, and outdoor activities in open areas would require completely different safety protocols. Before we continue with our countdown of prehistoric nightmares, let me take a moment to remind you that we're only halfway through this terrifying journey. If you're enjoying this exploration of creatures that make horror movies look like children's bedtime stories, make sure to hit that like button and subscribe for more content that'll make you grateful for the relatively peaceful world we live in today. Trust me, the creatures we haven't covered yet are going to make everything we've discussed so far look like harmless pets. Number 10 brings us to Megalania, a creature that might explain why dragon legends appear in cultures all around the world. This extinct monitor lizard was essentially what would happen if someone took a Komodo dragon and decided it needed to be 3 times larger and significantly more aggressive. We're talking about a terrestrial lizard that could grow to 20 feet in length and weigh as much as a small car. What made Megalania particularly terrifying wasn't just its size, though 20 feet of predatory reptile is certainly intimidating enough. This creature was equipped with all the hunting instincts and natural weapons of modern monitor lizards, but scaled up to proportions that would make even the largest crocodiles think twice about confrontation. Its bite was venomous. Its claws were designed for gripping struggling prey, and its tail could be used as a devastating weapon. The fossil evidence suggests that Megalania lived in Australia during the Pleistocene epoch, which means it was sharing the continent with early human settlers. Archaeological sites show evidence of encounters between humans and these giant lizards, and the results weren't pretty for either species. Megalania probably saw early humans as just another prey species, while humans had to develop entirely new hunting strategies to deal with reptilian predators the size of buses. What's particularly unsettling about Megalania is how it represents the extreme end of reptilian evolution. Modern monitor lizards are already impressive predators with complex behaviors and sophisticated hunting techniques. Megalania took all those traits and amplified them to absolutely massive proportions, creating a predator that could dominate entire ecosystems through sheer size and aggression. The extinction of megalania probably coincided with the arrival of human settlers in Australia, though climate change also played a role. These giant lizards required enormous amounts of food to sustain their massive bodies, and as large prey species disappeared, so did the apex predators that depended on them. Number 9 introduces us to Deinosuchus, a crocodilian that makes modern saltwater crocodiles look like harmless lizards. The name literally means terrible crocodile, and trust me, that's not hyperbole. These prehistoric monsters could grow to 35 feet in length and had bite forces that exceeded those of tyrannosaurs. Picture a crocodile the size of a school bus with jaws that could crush car engines, and you're starting to get an idea of what Deinosuchus was capable of. What made these creatures particularly nightmarish was their hunting strategy. Modern crocodiles are ambush predators that wait patiently for prey to come to them, but Deinosuchus was large enough and powerful enough to actively hunt whatever it wanted. Fossil evidence shows bite marks from Deinosuchus on dinosaur bones, which means these aquatic monsters were regularly taking down some of the largest land animals that ever lived. The really terrifying aspect of Deinosuchus is how it dominated both aquatic and terrestrial hunting grounds. These creatures could hunt in deep water like modern crocodiles, but they were also capable of pursuing prey onto land when the opportunity arose. Nothing was safe from a predator that could operate effectively in multiple environments and had the size advantage over almost everything else alive. Fossil sites in North America have revealed evidence of Deinosuchus feeding behavior, and the results are genuinely disturbing. These creatures weren't just opportunistic scavengers. They were systematic hunters that could take down prey much larger than themselves through superior bite force and incredible persistence. They were essentially living proof that sometimes evolution decides to take successful designs and make them absolutely terrifying. The extinction of Deinosuchus probably resulted from changing climate conditions and the disappearance of the large prey species they depended on. But imagine if they had survived to modern times. River systems across North America would be completely off limits to human activity, and entire ecosystems would be organized around avoiding areas where these giant crocodilians might be lurking. Number 8 brings us to Platybelodon, a creature that shows us elephants could have been even more intimidating than they already are. This prehistoric proboscidean looked like someone had taken a modern elephant and decided it needed a massive shovel attached to its lower jaw. We're talking about a creature that could use its modified jaw like a backhoe, scooping up aquatic vegetation with mechanical efficiency. Now, you might think that being herbivorous would make Platybelodon less threatening than the carnivorous monsters we've been discussing. But consider this. Modern elephants are already among the most dangerous animals in Africa, despite being plant eaters. Now, imagine one with a jaw modification that essentially turned its mouth into a giant cutting tool. And you start to understand why Platybelodon deserves a spot on this list. The really unsettling aspect of this creature is how its jaw worked. The lower mandible was extended into a flat, spade-like structure lined with sharp incisors. This wasn't just for scooping up plants. It was a precision-cutting instrument that could slice through tough vegetation with ease. And if something that powerful was designed for cutting plants, imagine what it could do to anything made of softer material. Platybelodon lived during the Miocene epoch across Africa, Asia, and parts of Europe, which means these creatures were widespread and successful in their ecological niche. The fossil evidence suggests they were social animals that lived in herds, which means encountering one would likely mean dealing with an entire group of elephant-sized creatures equipped with natural cutting tools. The extinction of Platybelodon probably resulted from changing climate conditions and the evolution of more efficient feeding strategies in later elephant species. But imagine trying to cross rivers or wetlands knowing that herds of these creatures might be feeding in the area. Even if they weren't actively aggressive, their feeding behavior would make them incredibly dangerous to anything that got too close. Moving on to number 7, we return to aquatic nightmares with Helicoprion, a shark that evolution decided needed the most disturbing mouth design in the history of predatory fish. Picture a shark, but instead of normal teeth that shed and replace regularly, imagine one that just kept growing new teeth and pushing the old ones forward into a spiral of cutting edges that would make a buzzsaw jealous. The really horrifying thing about Helicoprion is that scientists spent decades trying to figure out how this tooth arrangement could possibly work. The fossil evidence clearly showed this spiral tooth whirl, but nobody could understand how a shark could actually use such a bizarre feeding mechanism. Recent research suggests the whirl functioned like a combination cutting blade and grasping mechanism, allowing the shark to slice through prey while simultaneously holding it in place. What makes this creature particularly nightmarish is how it represents evolution, experimenting with truly alien solutions to predatory challenges. Most sharks throughout history have stuck with variations of the basic tooth replacement system we see today. Helicoprion decided to try something completely different, creating a feeding mechanism that looks more like industrial machinery than biological adaptation. The fossil record shows that Helicoprion was successful enough to survive for millions of years, which means this bizarre tooth arrangement was actually an effective hunting strategy. These creatures were apex predators in their marine environments, using their unique mouth design to process prey in ways that conventional sharks couldn't match. Imagine being an ancient marine creature and encountering something like this. Modern sharks are already terrifying enough with their normal teeth, but Helicoprion took that basic design and turned it into something that looks like it belongs in a horror movie about mechanical monsters. The psychological impact alone would probably be enough to traumatize any creature that survived an encounter. Number 6 takes us into the realm of terrestrial arthropods, with Arthropleura, a millipede that someone decided needed to be the size of a small car. We're talking about an invertebrate that could grow to 8 feet in length and probably weighed as much as a large person. Picture the biggest millipede you've ever seen. Then imagine scaling it up until it's large enough to look you in the eye while rearing up on its hind segments. Now, modern millipedes are generally harmless creatures that feed on decaying plant matter and pose no threat to anything larger than themselves. But when you scale something up to the size of Arthropleura, even peaceful behavior becomes potentially dangerous. A creature that size moving through underbrush would sound like a small bulldozer, and if it decided to rear up defensively, it would be tall enough to block doorways. What makes Arthropleura particularly unsettling is how it represents a time when arthropods ruled terrestrial ecosystems. Before mammals became dominant, before reptiles reached their peak diversity, giant insects and their relatives controlled land-based food webs. Arthropleura was essentially the largest land invertebrate that ever lived, a testament to just how successful the arthropod body plan could be under the right conditions. The fossil evidence suggests that these giant millipedes lived in the extensive swamp forests of the Carboniferous period, feeding on the abundant plant material that characterized those ancient ecosystems. They were probably relatively peaceful creatures, but their sheer size would have made them formidable obstacles for any other organism trying to navigate the same environment. The extinction of Arthropleura probably resulted from changing atmospheric conditions and the evolution of more efficient vertebrate competitors. But imagine hiking through a forest and encountering something like this. Even knowing it was herbivorous wouldn't make the experience any less terrifying when you're face to face with an invertebrate the size of a motorcycle. Number 5 brings us to Leviathan melvillei, a prehistoric whale that makes modern sperm whales look like dolphins. Named after the biblical sea monster Leviathan, this creature was essentially what would happen if someone took a sperm whale and decided it needed to be optimized for hunting other whales. We're talking about a marine predator with the largest teeth ever discovered and the size advantage to use them effectively. What made Leviathan particularly terrifying was its specialization for hunting large prey. Modern sperm whales primarily feed on squid and fish, but Leviathan was equipped for taking down other whales, including some of the largest marine creatures that ever lived. Its teeth were over a foot long and designed for gripping and tearing rather than just holding slippery prey. The really impressive thing about Leviathan is how it competed directly with Megalodon for dominance of ancient oceans. These two apex predators shared the same time period and probably the same hunting grounds, which means prehistoric seas were essentially battlegrounds between whale-sized predators with completely different hunting strategies. Leviathan used intelligence and coordination, while Megalodon relied on size and bite force. Fossil evidence suggests that Leviathan was a social hunter that could coordinate attacks on large prey. Picture a pod of these creatures working together to take down prey the size of modern blue whales, using their massive teeth and superior intelligence to overcome even the largest targets. It was like having a pack of wolves, but each wolf was 60 feet long and equipped with foot-long teeth. The extinction of Leviathan probably resulted from changing ocean conditions and the disappearance of the large prey species it specialized in hunting. But imagine if these creatures had survived to modern times. Whale watching would be an entirely different activity, and commercial shipping would have to account for the possibility of encountering pods of predatory whales with the equipment and inclination to attack large vessels. Number 4 introduces us to Camarasaurus, a cephalopod that redefined everything we thought we knew about how large squid-like creatures could grow. This ancient nautiloid could reach 40 feet in length and weighed over a ton, making it one of the largest predatory invertebrates that ever lived. Picture a squid the size of a school bus with a conical shell and all the hunting instincts of modern cephalopods, but scaled up to absolutely massive proportions. What made Camarasaurus particularly formidable was its combination of size, intelligence, and specialized hunting equipment. Like modern cephalopods, it probably had excellent eyesight, rapid color-changing abilities, and highly flexible tentacles equipped with powerful suckers. But unlike modern squid that hunt fish and smaller prey, Camarasaurus was large enough to consider almost anything in the ocean as potential food. The fossil evidence suggests that Camarasaurus was an active predator that used its massive shell as both protection and a buoyancy control system. It could adjust its position in the water column to ambush prey from above or below, using its tentacles to grab victims and its powerful beak to process them efficiently. It was essentially a living submarine equipped with grappling arms and industrial-strength cutting tools. What's particularly unsettling about Camarasaurus is how it represents the extreme end of cephalopod evolution. Modern giant squid are already impressive predators with complex behaviors and sophisticated hunting techniques. Camarasaurus took all those traits and amplified them to proportions that would have made it a dominant force in any marine ecosystem. The extinction of Camarasaurus probably resulted from changing ocean chemistry and the evolution of more efficient predators. But imagine if these creatures had survived to modern times. Deep-sea exploration would be significantly more dangerous, and commercial fishing in certain areas would be essentially impossible due to the risk of encountering these massive cephalopod predators. Number 3 brings us to megapiranha, a fish that takes everything terrifying about modern piranhas and scales it up to nightmare proportions. We're talking about piranhas the size of surfboards with double the teeth and all the aggressive feeding behavior that makes their modern relatives so feared. Picture a 3-foot-long piranha with 2 rows of razor-sharp teeth, where modern species only have 1. And you're starting to understand what made these prehistoric fish so formidable. What made megapiranha particularly terrifying was its feeding strategy. Modern piranhas are already efficient at stripping flesh from bone using coordinated group attacks. But megapiranha was large enough to be dangerous even as individual predators. Their massive size meant they could attack prey that modern piranhas wouldn't dare approach, including other large predators and possibly even early whales or marine reptiles. The really disturbing aspect of these creatures is how they combine the pack hunting instincts of modern piranhas with individual size that made each fish a significant threat on its own. Imagine encountering a school of these creatures in ancient South American rivers. Modern piranha attacks are already dangerous enough when you're dealing with fish the size of dinner plates. But mega piranha could have easily killed large prey through individual attacks rather than requiring group coordination. Fossil evidence suggests that mega piranha lived alongside some of the other massive predators we've discussed, including titanoboa and giant crocodilians. The fact that they survived in ecosystems dominated by such enormous predators tells us something important about just how effective their hunting strategy was. They weren't just surviving. They were thriving in environments where most creatures were constantly fighting for their lives. The extinction of megapiranha probably resulted from changing river systems and the evolution of their prey species into forms that were better adapted to avoid piranha attacks. But imagine if they had survived to modern times. River travel in South America would be absolutely impossible, and entire ecosystems would be organized around avoiding areas where these massive predatory fish were known to hunt. Number 2 brings us to the most famous prehistoric predator of all, Megalodon, a shark so massive and so perfectly designed for killing that it's become the standard by which all other extinct predators are measured. We're talking about a shark that could grow to 60 feet in length with jaws large enough to swallow small cars and bite forces that exceeded anything else that ever lived in the ocean. What made Megalodon truly terrifying wasn't just its size, though 60 feet of predatory shark is certainly intimidating enough. It was the combination of size, speed, intelligence, and specialized hunting equipment that made these creatures the ultimate marine predators. Their teeth were 6 inches long and designed for cutting through bone. Their jaws could open wide enough to engulf entire whales, and their streamlined bodies allowed them to pursue prey at speeds that would challenge modern speedboats. The fossil evidence tells us that Megalodon was a global predator that dominated warm water marine environments for millions of years. These creatures hunted everything from small fish to the largest whales, and they were so successful that entire marine ecosystems were organized around either avoiding them or serving as their prey. They were essentially living proof that sometimes evolution creates predators so perfect that they become unstoppable forces of nature. What's particularly impressive about Megalodon is how it maintained its position as the ocean's apex predator for such an extended period. Most species that reach the top of their food webs eventually face challenges from changing environments or evolving competitors. But Megalodon dominated ancient seas for over 15 million years. They were so successful that their extinction required a global climate change event to finally end their reign. The extinction of Megalodon probably resulted from cooling ocean temperatures and the disappearance of the large whale species they specialized in hunting. But imagine if these creatures had survived to modern times. Ocean travel would be fundamentally different. Coastal communities would face entirely different challenges, and marine ecosystems would be organized around avoiding areas where these massive predators were known to hunt. Moving on to our final and most terrifying entry, we reached number 1 on our countdown of prehistoric nightmares. Ladies and gentlemen, meet Arctotherium angustidens, a bear that makes modern grizzlies look like teddy bears at a children's picnic. We're talking about a creature that stood over 11 feet tall on its hind legs and weighed as much as a small elephant. Picture the largest, most aggressive bear you can imagine. Then multiply that by about 10, and you're starting to get an idea of what our ancestors had to deal with when these monsters roamed the earth. What made Arctotherium absolutely terrifying wasn't just its massive size, though being face to face with something that could look down at professional basketball players would certainly be intimidating enough. These creatures were hyper-carnivores, which means they were specifically evolved for hunting and eating meat. Unlike modern bears that supplement their diet with plants, berries, and fish, Arctotherium was built from the ground up to be a killing machine that needed massive amounts of fresh meat to survive. The fossil evidence tells us that these giant bears required somewhere around 35 pounds of meat per day just to maintain their enormous body mass. That's not scavenging we're talking about. That's active, aggressive hunting on a scale that would make modern apex predators look like weekend hobbyists. These creatures had to kill something substantial almost every single day, and with their size advantage, almost everything else on the continent qualified as potential prey. What's particularly unsettling about Arctotherium is how recently they shared the planet with early human civilizations. We're not talking about creatures that vanished with the dinosaurs or disappeared during some ancient mass extinction event. These monsters were prowling around North and South America until approximately 11,000 years ago, which means they were contemporary with the first human settlements in the Americas. Imagine being among the first humans to cross the Bering Land Bridge into North America, hoping to find new hunting grounds and establish permanent settlements, only to discover that the continent was already dominated by bears the size of small buildings. These weren't the kind of predators you could scare away with fire or avoid by climbing trees. Arctotherium was perfectly capable of knocking down any tree you might climb and had no particular fear of human technology. The hunting strategy of these giant bears was probably similar to modern grizzlies, but scaled up to absolutely devastating proportions. They would have used their incredible sense of smell to track prey across vast distances, their massive claws to bring down struggling victims, and their bone-crushing jaws to finish the job efficiently. But unlike modern bears that primarily hunt smaller prey or rely on seasonal feeding opportunities, Arctotherium had to be constantly hunting just to meet its enormous caloric requirements. Archaeological evidence suggests that early human populations in the Americas had to develop entirely new survival strategies to deal with these massive predators. Traditional hunting techniques that worked against smaller predators were completely useless against something the size of Arctotherium. These bears could probably shrug off spear attacks that would kill most other large mammals, and their reach advantage meant that getting close enough for effective weapons use was essentially a suicide mission. What makes Arctotherium even more terrifying is how it represents the absolute peak of mammalian predator evolution. Evolution had spent millions of years refining the bear body plan, making it more efficient, more powerful, and more successful at hunting. Arctotherium was the end result of that process. A predator so perfectly adapted for killing that it dominated entire continents through sheer physical superiority. The social behavior of these creatures is still debated by scientists. But if they were anything like modern bears, they were probably solitary hunters that came together only for mating. That means the landscape of ancient America was dotted with individual killing machines, each one requiring massive hunting territories to sustain their enormous appetites. Encountering one would be bad enough, but knowing that there were probably dozens of others scattered across the region would make long-distance travel essentially impossible. The extinction of Arctotherium coincided with major climate changes at the end of the last ice age, but human hunting pressure probably played a role as well. As early Americans developed more sophisticated weapons and hunting techniques, they began competing directly with these giant bears for the same large prey species. When the climate started changing and large herbivores became less common, both humans and Arctotherium found themselves fighting over increasingly scarce resources. What's fascinating about this extinction event is how it represents one of the few cases where early humans actually contributed to the disappearance of a creature that was clearly superior to them in terms of individual combat capability. Arctotherium could easily kill any human in a direct confrontation, but humans had advantages in tool use, coordination, and adaptability that eventually proved decisive in the long-term struggle for continental dominance. The fossil record shows evidence of direct confrontations between humans and Arctotherium, and the results paint a picture of desperate struggles between two apex predator species competing for the same ecological niche. Bone sites show human tools mixed with bear remains, suggesting that our ancestors were actively hunting these massive creatures despite the enormous risks involved. Imagine the courage it would have taken for early Americans to actively hunt something like Arctotherium. These weren't opportunistic attacks on sick or injured animals. Archaeological evidence suggests that humans were systematically targeting healthy adult bears that were perfectly capable of defending themselves. It was essentially David versus Goliath, except Goliath weighed 3,000 pounds and had claws the size of railroad spikes. The successful extinction of Arctotherium represents a turning point in human history, the moment when our species proved that intelligence and cooperation could overcome even the most physically superior predators. But it came at an enormous cost in human lives, and probably required generations of accumulated knowledge about bear behavior, hunting strategies, and weapon effectiveness. If Arctotherium had survived to modern times, the entire course of human civilization would have been different. Major cities would have had to be built with completely different defensive considerations. Agriculture would have been nearly impossible in many regions due to the constant threat of bear attacks on livestock and farmers. Even today's most advanced weapons would be necessary just for basic survival in areas where these creatures were known to hunt. The psychological impact of living alongside predators like Arctotherium would have been profound. Modern humans already have deep-seated fears of large predators, despite the fact that most of us will never encounter anything more dangerous than an aggressive dog. Imagine if those fears were based on real daily threats from creatures that could break down reinforced doors and had no particular reason to fear human settlements. Transportation across continents would have remained essentially impossible until the development of heavily armed expeditions. The idea of casual travel, recreational hiking, or outdoor sports would never have developed in a world where leaving protected settlements meant risking encounters with 3,000-pound killing machines that actively hunted anything that moved. The agricultural revolution that allowed humans to develop complex civilizations might never have occurred if farmers had to worry about bear attacks on their crops and livestock. Even modern farming equipment would be insufficient protection against predators capable of overturning small vehicles and breaking through reinforced barriers with ease. But perhaps most significantly, the development of human settlements would have been completely different. Cities would have needed to be built like fortresses, with walls thick enough to keep out creatures that could probably break through most modern residential construction. The entire concept of suburban living would be impossible when your neighbors might include predators that consider humans a dietary staple. The extinction of creatures like Arctotherium allowed humanity to develop into the dominant species on Earth. But it also meant that we lost our connection to the raw, primal struggle for survival that shaped our ancestors for millions of years. Modern humans live in a world that's been sanitized of the kinds of threats that once defined daily existence. And while that's certainly made life more comfortable, it's also created a species that's largely disconnected from the natural world our ancestors had to navigate. Looking back at our complete countdown of these 24 prehistoric nightmares, what becomes clear is that extinction isn't always the tragedy we usually consider it to be. Each of these creatures represents a world where humans would have been nothing more than another prey species, struggling to survive in ecosystems dominated by predators that were perfectly designed for hunting and killing anything smaller than themselves. The disappearance of these creatures allowed for the development of complex ecosystems where smaller, more adaptable species could thrive. It created opportunities for evolutionary experimentation that eventually led to the incredible diversity of life we see today. And most importantly for our purposes, it allowed a species of relatively defenseless primates to eventually develop the tools and strategies necessary to become the dominant force on the planet. But understanding these extinct predators also gives us valuable perspective on our current relationship with the natural world. Every time we encounter a modern apex predator, whether it's a great white shark, a grizzly bear, or even an aggressive wasp, we're getting just a tiny taste of what daily life was like for our ancestors. The fear response we feel when confronted by potentially dangerous animals isn't paranoia. It's an evolutionary adaptation that kept our species alive long enough to develop the civilizations we enjoy today. The fossil record of these creatures also reminds us that the Earth has supported forms of life that are almost impossible to imagine. Evolution has experimented with body plans, hunting strategies, and ecological relationships that seem more like science fiction than natural history. The fact that these experiments actually worked for millions of years tells us something profound about the adaptability and creativity of life itself. Perhaps most importantly, studying these extinct predators helps us appreciate just how remarkable human survival actually is. Our ancestors didn't just survive in a world dominated by creatures like Arctotherium. They thrived well enough to eventually become the dominant species on the planet. That's not just lucky. It's a testament to the power of intelligence, cooperation, and adaptability in the face of seemingly impossible challenges. The next time you're walking through a peaceful forest, swimming in a calm lake, or simply enjoying a quiet evening outdoors, take a moment to appreciate just how different your experience would be if any of these 24 creatures were still around. The fact that you can enjoy nature without constantly watching for massive predators is a luxury that our ancestors could never have imagined, and it's a direct result of extinction events that cleared the way for a more peaceful world. So, while we should certainly continue working to preserve endangered species and protect biodiversity, it's worth remembering that not every extinction represents a loss for the overall balance of life on Earth. Sometimes, the disappearance of one species creates opportunities for dozens of others to flourish. And sometimes, the extinction of creatures that were perfectly designed for killing everything around them is exactly what the planet needed to support the incredible diversity of life we see today. These 24 prehistoric nightmares remind us that the natural world has always been a place of incredible creativity, remarkable adaptation, and sometimes absolutely terrifying predators. The fact that we can study them safely from the comfort of our modern world, rather than having to avoid them while trying to gather food or build shelters, is one of the greatest gifts that extinction has ever given to humanity. The Earth's history is filled with creatures that would challenge our most creative horror writers to come up with something equally terrifying. But it's also filled with evidence that life finds ways to survive, adapt, and eventually thrive, even in the face of predators that seem designed to make survival impossible. That's a lesson worth remembering as we face our own challenges in an ever-changing world. And there you have it. 24 deadly animals that you should be absolutely grateful are no longer sharing our planet. From massive land predators that could outrun sports cars to flying monsters that could cast shadows over entire cities. From ocean nightmares that turned swimming into a death sentence to insects that could hunt vertebrates for food. We've covered creatures that redefined what it means to be a successful predator. Each of these species dominated their environments for millions of years, proving that their terrifying designs weren't just evolutionary accidents. They were successful strategies for survival in worlds that were fundamentally different from the one we inhabit today. Their extinction created the space necessary for smaller, more adaptable species to diversify and eventually create the rich ecosystems we see around us. The study of these creatures gives us invaluable insights into the history of life on Earth, the process of evolution, and the remarkable adaptability that has allowed life to survive multiple mass extinction events. But perhaps most importantly, it gives us a deep appreciation for the relatively peaceful world we've inherited, where the most dangerous predators we're likely to encounter are nothing compared to the monsters that once ruled land, sea, and sky. So the next time you're worried about sharks while swimming, bears while hiking, or spiders in your basement, just remember that you're living in the most predator-friendly time in Earth's history. The creatures that would have considered you an appetizer have been gone for thousands or millions of years, leaving behind a world where humans can not only survive, but actually thrive as the dominant species on the planet. That's something worth being grateful for, and it's definitely something worth remembering the next time you think the natural world isn't dangerous enough to keep life interesting. Trust me, there was a time when it was plenty dangerous enough, and we should all be thankful that time has passed. But wait, we're not done yet. If you thought those 24 creatures were the end of our journey through prehistoric terror, you're in for a surprise. Because the truth is, these extinct monsters didn't just disappear into the fossil record and leave us with a peaceful world. They left behind something far more unsettling, the knowledge that evolution is perfectly capable of creating killing machines so efficient, so perfectly adapted for destruction, that they can dominate entire planets for millions of years. What's really going to keep you awake tonight is understanding that every single one of these creatures we've discussed represents just one successful experiment in predatory evolution. For every megalodon that dominated ancient seas, there were probably dozens of other massive predators that didn't quite make it into the fossil record. For every terror bird that ruled prehistoric plains, there were likely countless other giant predators that left no trace of their existence. The fossil record is notoriously incomplete, which means we're only seeing a tiny fraction of the nightmarish creatures that actually lived on this planet. Scientists estimate that we've discovered less than 1% of all species that have ever existed, which means there are probably thousands of extinct predators out there that would make our list of 24 look like a collection of harmless pets. Think about that for a moment. We've just spent considerable time exploring creatures that could swallow humans whole, crush skulls with single bites, and hunt with the efficiency of military weapons. And these represent just the tip of the iceberg when it comes to prehistoric predators. The vast majority of Earth's most terrifying creatures have vanished without leaving any evidence of their existence, taking their horrifying secrets with them into deep time. But here's where things get really interesting, and maybe a little bit concerning. Evolution didn't stop creating predators when these ancient monsters went extinct. It just shifted strategies, developing new approaches to the eternal arms race between predators and prey. The creatures we see today are the direct descendants of survivors who had to compete with giants like Arctotherium and Megalodon, which means they're actually the products of evolutionary pressure from some of the most efficient killers that ever lived. Modern predators might be smaller than their prehistoric ancestors, but in many ways, they're actually more sophisticated. Today's apex predators have been refined by millions of years of additional evolution, developing hunting strategies, sensory capabilities, and behavioral complexities that would have impressed even the most successful ancient killers. Consider the modern great white shark, for example. Sure, it's not as large as megalodon, but it's actually a more efficient predator in many ways. Great whites have better sensory systems, more sophisticated hunting behaviors, and greater adaptability to changing environmental conditions. They represent the distilled essence of shark evolution, stripped of unnecessary bulk and optimized for success in modern oceans. The same principle applies to land predators. Modern big cats might not be as massive as saber-toothed cats, but they're incredibly sophisticated hunters with complex social behaviors, advanced problem-solving abilities, and hunting techniques that would challenge military strategists. They're not just killing machines, they're intelligent killing machines that can adapt their strategies based on changing circumstances. And this brings us to perhaps the most unsettling realization of all. If evolution was capable of creating creatures like Arctotherium and Megalodon in the past, what's to stop it from doing so again in the future? The same evolutionary pressures that produced those ancient monsters are still operating today, and they're perfectly capable of creating new generations of apex predators that could make our list of extinct nightmares look outdated. Climate change, shifting ecosystems, and changing prey availability create exactly the kind of evolutionary pressure that tends to produce dramatic adaptations in predator species. We could be looking at the early stages of evolutionary processes that will eventually create predators even more terrifying than anything we've discussed today. But here's the twist that really changes everything. Humans have now become the dominant evolutionary pressure on planet Earth. Our activities are driving changes in ecosystems, climate, and species distribution at rates that far exceed anything in the geological record. We're essentially conducting a planet-wide evolutionary experiment, and we have no idea what kinds of predators might emerge as a result. Some scientists argue that we're already seeing the early stages of this process in action. Urban adapted predators are evolving new hunting strategies specifically designed to exploit human-modified environments. Coyotes are learning to navigate city streets, mountain lions are adapting to suburban landscapes, and various bird species are developing techniques for hunting in areas dominated by human activity. These might seem like minor adaptations now, but remember that evolution works on time scales that make human civilization look like a brief moment. The predators that are learning to exploit human environments today could be the ancestors of creatures that eventually evolved to specialize in hunting humans specifically. And that's not even considering the possibility of human-driven evolution through genetic modification, selective breeding, or other technological interventions. We already have the capability to modify organisms at the genetic level, and it's not difficult to imagine scenarios where those capabilities could be used to create predators more efficient than anything nature has produced on its own. The history of biological warfare research shows us that humans are perfectly willing to weaponize living organisms when it serves their purposes. It's not a huge leap to imagine future conflicts where genetically modified predators are used as living weapons, designed specifically to hunt human targets with efficiency that would make our prehistoric nightmares look like amateur efforts. But let's step back from these darker possibilities and focus on something more immediate and perhaps more relevant to our daily lives. The creatures we've discussed today didn't just disappear. They left behind genetic legacies that continue to influence the modern world in ways that most people never consider. Every time you feel that primal fear when something moves in your peripheral vision, you're experiencing an evolutionary adaptation that kept your ancestors alive in a world dominated by creatures like saber-toothed cats and giant bears. That split-second fight or flight response that kicks in when you're startled isn't just a quirk of human psychology. It's a survival mechanism that was literally carved into our genetics by millions of years of predation pressure. The reason horror movies are so effective at frightening us isn't just because we have active imaginations. It's because they tap into deep-seated fears that were essential for survival when our ancestors shared the planet with real monsters. Every time you feel your heart rate spike during a scary movie, you're experiencing the same physiological response that kept early humans alive when giant predators were a daily reality. These evolutionary adaptations go far beyond simple fear responses. The way we organize our living spaces, the foods we prefer, our social structures, and even our sleep patterns have all been influenced by the need to survive in a world where massive predators were constantly hunting anything that moved. The fact that humans are naturally drawn to elevated sleeping areas, for example, probably reflects adaptations that helped our ancestors avoid ground-dwelling predators like Arctotherium. Our preference for foods that can be prepared quickly and consumed rapidly likely developed, because lengthy meal preparation was dangerous when giant predators could attack at any moment. Even our social behaviors show clear influences from predation pressure. The human tendency to form tight-knit groups, establish territories, and develop complex communication systems all make perfect sense when you consider that our ancestors had to coordinate their activities to avoid being picked off by creatures that could kill individuals but might be deterred by organized groups. But perhaps most significantly, the extinction of these massive predators fundamentally altered the trajectory of human evolution itself. Without the constant pressure of avoiding creatures like terror birds and giant monitor lizards, our ancestors had the freedom to develop larger brains, more sophisticated tools, and eventually the complex civilizations that define modern human society. The energy that would have been devoted to predator avoidance could instead be channeled into activities like art, science, philosophy, and technology. The time that would have been spent hiding from monsters could be used for exploration, experimentation, and the gradual accumulation of knowledge that eventually led to our current understanding of the natural world. In a very real sense, the extinction of these prehistoric predators was the event that made human civilization possible. Without that extinction, we might still be living in small scattered groups, constantly moving to avoid apex predators, never staying in one place long enough to develop agriculture, permanent settlements, or the complex social structures that allow for scientific advancement. This raises fascinating questions about the relationship between predation pressure and intelligence in evolutionary history. Did the presence of massive predators actually accelerate human brain development by creating strong selection pressure for problem-solving abilities, strategic thinking, and social cooperation? Or did their extinction remove barriers that had been preventing our species from reaching its full intellectual potential? The archaeological record suggests that both processes were probably important at different stages of human evolution. Early human development was clearly shaped by the need to survive alongside massive predators. But the rapid advancement of human civilization seems to have coincided with the disappearance of the largest and most dangerous species. This pattern has implications that extend far beyond human evolution. The extinction of apex predators doesn't just affect their immediate prey species. It fundamentally alters the evolutionary pressures operating throughout entire ecosystems. When creatures like megalodon disappear from marine environments, it creates opportunities for smaller species to diversify, explore new ecological niches, and eventually evolve into forms that would have been impossible in the presence of such dominant predators. The same principle applies to terrestrial ecosystems. The extinction of giant ground sloths, massive birds, and enormous reptiles created evolutionary space for the incredible diversity of mammals we see today. Many of the species we consider iconic, from elephants to tigers to whales, might never have evolved if they'd had to compete with the prehistoric giants we've been discussing. But this also means that current conservation efforts are taking place in ecosystems that have already been fundamentally altered by past extinctions. The natural world we're trying to preserve isn't actually natural in the sense of being unchanged by extinction events. It's a world that has been shaped by the disappearance of creatures that once dominated every major ecosystem on the planet. This historical perspective changes how we think about current conservation challenges. When we talk about protecting endangered species, we're often trying to preserve remnants of ecosystems that were once dominated by creatures that no longer exist. The predators and prey relationships we see today are actually the survivors of much more complex and dangerous ecological networks that included apex predators capable of hunting almost anything. Understanding this history also helps explain why some modern conservation efforts face unexpected challenges. Ecosystems that evolved in the absence of their original apex predators sometimes behave in ways that seem counterintuitive because they're operating with incomplete food webs and altered predation pressures. The reintroduction of wolves to Yellowstone National Park, for example, had cascading effects throughout the entire ecosystem that scientists are still studying decades later. If reintroducing a single predator species can cause such dramatic changes, imagine what the original presence of creatures like Arctotherium and terror birds must have meant for ecosystem stability and species interactions. This brings us to one of the most profound implications of our journey through prehistoric predators. The creatures we've discussed didn't just exist. They were integral parts of complex ecological networks that supported incredible diversity and maintained environmental stability for millions of years. Their extinction didn't just remove individual species. It dismantled entire systems of relationships that had been refined by evolution over vast periods of time. The world we inhabit today is essentially an ecological experiment that began with the mass extinction of megafauna at the end of the last ice age. We're living in ecosystems that are still adjusting to the absence of their original apex predators. And we're seeing the results of that adjustment process in everything from climate patterns to species distribution to the behavior of surviving predators. Modern apex predators like lions, tigers, and great white sharks are operating in ecosystems that were originally designed around much larger and more dominant predators. They're filling ecological roles that were once occupied by creatures 2 or 3 times their size, which means they're probably having to work much harder to maintain the same level of ecosystem control that their prehistoric predecessors achieved effortlessly. This also suggests that current predator populations might be more vulnerable to disruption than we realize. If modern apex predators are already stretched thin, trying to fill ecological roles that were originally designed for much larger creatures, then additional pressure from human activities, climate change, or habitat loss could push them past their breaking point much more quickly than we expect. The implications extend to human activities as well. Our agricultural systems, urban planning, and resource management strategies are all based on assumptions about predator behavior and ecosystem stability that were developed in a world where the largest predators had already been extinct for thousands of years. We've never had to design human civilization around the presence of creatures like megalodon or Arctotherium, which means we have no experience with the kinds of challenges that truly dominant predators can create. But as we've seen throughout this exploration, evolution is perfectly capable of creating new apex predators when environmental conditions are right. The same processes that produced the prehistoric monsters we've discussed are still operating today, and they're being influenced by human activities in ways that could accelerate the development of new predatory species. Climate change is creating new environmental pressures that could drive rapid evolutionary changes in existing predator species. Rising temperatures, shifting weather patterns, and changing prey availability are exactly the kinds of factors that have historically led to the evolution of larger, more aggressive, and more efficient predators. Ocean acidification and warming seas are changing marine ecosystems in ways that could favor the evolution of new types of oceanic predators. As traditional prey species adapt to changing conditions, predator species will be under pressure to develop new hunting strategies, potentially leading to the evolution of creatures that could rival the ancient sea monsters we've discussed. On land, Habitat fragmentation and urbanization are creating new types of environments that could select for predators specifically adapted to hunting in human-modified landscapes. Urban coyotes, suburban mountain lions, and city-dwelling raptors are already showing behavioral adaptations that could be the first steps toward the evolution of predators specifically designed to exploit human environments. The really unsettling possibility is that human activities might actually be creating environmental conditions that favor the evolution of predators capable of hunting humans specifically. As we continue to modify ecosystems and create new types of environments, we might inadvertently be setting up evolutionary pressures that could produce the next generation of apex predators. And unlike the prehistoric predators we've discussed, these new apex predators would be evolving in a world where humans are already the dominant species. They would be developing hunting strategies specifically designed to overcome human defenses, exploit human behaviors, and succeed in environment that humans have created for their own purposes. This scenario might sound like science fiction, but it's actually just an extension of evolutionary processes that we can already observe in action. Pest species regularly evolve resistance to human control methods. Invasive species adapt to new environments with remarkable speed, and urban wildlife populations show behavioral changes that occur over just a few generations. The same evolutionary flexibility that allows these smaller organisms to adapt to human activities could eventually produce larger predators with similar capabilities. And unlike the ancient monsters that evolved in worlds without humans, these new predators would be specifically adapted to succeed in a human-dominated world. But perhaps the most sobering realization from our exploration of prehistoric predators is how quickly and completely dominant species can disappear. Every one of the creatures we've discussed was, at one time, the undisputed ruler of its ecosystem. They had evolved to be perfectly adapted to their environments. They had no natural enemies, and they seemed destined to dominate their respective domains indefinitely. And yet, they all disappeared. Climate change, habitat loss, competition from new species, and various other factors eventually overwhelmed even the most successful predators in Earth's history. The same processes that eliminated megalodon, arctotherium, and terror birds are still operating today, and they're perfectly capable of eliminating any species, including humans. This perspective puts our current environmental challenges into a much broader context. We're not just dealing with short-term problems that can be solved with better technology or policy changes. We're participating in the same evolutionary processes that have been shaping life on Earth for billions of years. And those processes don't make exceptions for species that consider themselves intelligent or technologically advanced. The extinction of prehistoric predators teaches us that dominance in any ecosystem is always temporary. No matter how well adapted a species becomes, no matter how successfully it exploits its environment, changing conditions will eventually create new challenges that require new adaptations. Species that can't keep up with those changes will disappear, regardless of how successful they were in the past. For humans, this means that our current dominance of Earth's ecosystems is not a permanent achievement. We're subject to the same evolutionary pressures that eliminated every other apex predator in the planet's history. The only question is whether we're adaptable enough to survive the changes we're creating in our own environment. The creatures we've explored today represent both a warning and an inspiration. They show us what evolution is capable of creating when environmental pressures favor the development of efficient predators. But they also show us that even the most successful species can disappear when they can't adapt to changing conditions. Our exploration of these 24 extinct predators has taken us on a journey through deep time, showing us worlds where the rules of survival were written by creatures that dwarf anything alive today. We've seen evolution's capacity for creating monsters that seem too terrifying to be real. And we've learned that extinction isn't always the tragedy we usually consider it to be. But most importantly, we've gained perspective on our own place in the long history of life on Earth. We're not separate from the natural world. We're participants in evolutionary processes that have been operating for billions of years. The same forces that created and eliminated the prehistoric monsters we've discussed are still shaping life today, including human life. The next time you encounter a modern predator, whether it's a shark, a bear, or even an aggressive house cat, remember that you're looking at a survivor. Every predator alive today is the descendant of creatures that had to compete with giants, avoid extinction events, and adapt to constantly changing environments. They represent successful experiments in survival that have passed every test that evolution could devise. And the next time you feel grateful for the relative safety of the modern world, remember that this safety is not a permanent condition. It's a temporary state that exists because the most dangerous predators in Earth's history happened to go extinct before they could prevent human civilization from developing. That extinction was not inevitable, and there's no guarantee that future predators won't evolve to fill the ecological roles that creatures like Arctotherium and Megalodon once occupied. The study of extinct predators reminds us that the natural world is far more dynamic, creative, and potentially dangerous than most people realize. Evolution has produced creatures that challenge our understanding of what's possible in the biological world, and it's perfectly capable of doing so again in the future. But it also reminds us that life is incredibly resilient and adaptable. Despite multiple mass extinction events, climate changes, and environmental catastrophes, life has not only survived but thrived, producing new forms of incredible complexity and beauty. The same processes that created prehistoric monsters have also created every form of life we see around us today, from the smallest bacteria to the largest whales. As we face our own environmental challenges and contemplate an uncertain future, the history of prehistoric predators offers both sobering warnings and reasons for hope. It shows us that dominant species can disappear with surprising speed, but it also demonstrates that life finds ways to adapt, survive, and eventually flourish, even in the face of seemingly impossible challenges. The 24 creatures we've explored today are gone forever, but their legacy lives on in the evolutionary adaptations of every species that survived their reign of terror. They shape the world we inhabit in ways we're only beginning to understand, and their influence continues to affect everything from our deepest fears to our most sophisticated conservation strategies. So, the next time you're enjoying a peaceful walk in nature, swimming in calm waters, or simply appreciating the relative predictability of the modern world, take a moment to remember the monsters that once made such simple pleasures impossible. Their extinction was not just lucky for humanity. It was essential for the development of the complex, diverse, and relatively peaceful world we're privileged to inhabit today. And perhaps most importantly, remember that our current safety and dominance are not permanent achievements. They're temporary conditions that require constant vigilance, adaptation, and respect for the natural processes that have shaped life on Earth for billions of years. The same evolution that created prehistoric nightmares is still operating today. And it's up to us to ensure that we can adapt to whatever challenges it might create in the future. The monsters are gone. The forces that created them are still very much alive. Understanding that reality is perhaps the most important lesson we can learn from our journey through the prehistory of predation. It's a lesson that could determine whether humanity joins the ranks of successful survivors or becomes just another entry in some future catalog of extinct apex predators. The truth is, when we talk about these vanished nightmares, we're really talking about a fundamental shift in how life on Earth operates. These weren't just random monsters that happened to die out. They were the architects of entire ecosystems, the creatures that everything else had to evolve around just to survive another day. Think about it this way. Every single adaptation you see in modern animals can be traced back to some ancestral need to either catch prey or avoid being caught. The speed of a gazelle, the camouflage of a chameleon, the venom of a snake. All of these incredible abilities developed because somewhere in the evolutionary past, there was a predator so efficient, so deadly, that only the most creative survival strategies could possibly work. But here's where things get really wild. The creatures we've been discussing weren't just successful because they were big and scary. They were successful because they represented evolutionary perfection in their respective environments. Each one was the end result of millions of years of natural selection, constantly refining and improving until you had predators that were essentially biological weapon systems. Take the concept of ambush hunting, for instance. Modern big cats are pretty good at it, but they're working with the leftovers of what used to be possible. When you had predators the size of buses lurking in prehistoric forests, ambush hunting wasn't just about patience and stealth. It was about turning entire landscapes into death traps, where prey had essentially no chance of escape. The psychological warfare aspect alone would have been devastating. Imagine being a herbivore in a world where the rustling of leaves could mean you're about to become lunch for something that could swallow you in a single bite. Every moment of every day would be spent calculating risks, choosing between feeding and safety, trying to second-guess predators that had millions of years of evolutionary refinement backing up their hunting strategies. And that's just talking about individual predators. Some of these creatures probably hunted in coordinated groups, using pack tactics that would make modern military strategists take notes. Picture a coordinated attack by multiple terror birds, each one the size of a small building, working together to corner prey that had nowhere to run and no hope of fighting back. The really unsettling part is how these predators shape the evolution of everything else around them. Modern herbivores have defense mechanisms that seem almost comically over-engineered until you realize they were developed to deal with threats that no longer exist. The armor plating on an armadillo makes a lot more sense when you consider it might have evolved to protect against predators with bone-crushing bite forces that exceeded anything alive today. Even plant evolution was influenced by these massive predators. Forest structures, plant toxins, growth patterns, all of these could have been shaped by the feeding behaviors of herbivores that were themselves constantly being hunted by creatures that could kill them in seconds. It was an arms race that involved every living thing, with predators driving adaptation at every level of the ecosystem. But let's talk about something that really puts the terror of these creatures into perspective: their sensory capabilities. Modern predators already have senses that put human abilities to shame. But imagine scaling that up to creatures with brains the size of basketballs and sensory organs that had millions of additional years to evolve specialized hunting capabilities. A megalodon probably had electroreception so sensitive it could detect the heartbeat of potential prey from miles away. Terror. Birds likely had eyesight so acute they could spot movement across vast distances that would be invisible to human observers. Giant bears would have had olfactory capabilities that could track prey across continents and through weather conditions that would completely mask scent trails from modern predators. The hunting range of these creatures would have been absolutely staggering. Modern apex predators typically control territories measured in square miles, but creatures like Arctotherium would have needed hunting grounds the size of entire states just to meet their caloric requirements. Imagine trying to establish any kind of permanent settlement when the local apex predator considers everything within 1,000 square miles to be its personal hunting preserve. And here's something that really challenges our understanding of prehistoric ecosystems. These massive predators probably had complex social behaviors that we can barely begin to comprehend. Modern predators already display remarkable intelligence, problem-solving abilities, and social coordination. Scale that up to creatures with brain-to-body ratios that allowed for genuinely sophisticated cognitive abilities. And you're talking about predators that could plan, strategize, and adapt their hunting techniques based on the behavior of their prey. Some of these creatures might have been capable of what we'd recognize as tactical thinking. They could have analyzed the defensive strategies of their prey species and developed countermeasures that stayed ahead of evolutionary adaptations. It would have been like an ongoing chess match between predators and prey, except the chess pieces were living creatures and the stakes were literally life and death. The communication systems these predators used would have been equally sophisticated. Modern wolves coordinate pack hunts using complex vocalizations and body language. Now, imagine that level of coordination scaled up to creatures that could communicate across vast distances using infrasonic calls, chemical signals, or other methods that we're only beginning to understand in modern animals. A coordinated hunt by a pack of giant predators would have been like a military operation. They could have used scouts to locate prey, established ambush positions that took advantage of terrain features, and executed complex maneuvers that trapped entire herds of animals with no possibility of escape. The precision and efficiency would have been absolutely terrifying to witness. But perhaps most disturbing of all is the realization that these creatures were constantly evolving, constantly improving their hunting abilities in response to the defensive adaptations of their prey. Evolution doesn't stand still, and predators that dominated their ecosystems for millions of years had to be continuously innovating just to maintain their position at the top of the food chain. This means that by the time these creatures went extinct, they had reached levels of predatory efficiency that represented millions of years of constant refinement. They weren't just the first draft of what evolution could produce. They were the final, polished versions of predatory perfection, honed by countless generations of life and death competition. The extinction events that eliminated these creatures didn't just remove individual species from the ecosystem. They ended evolutionary experiments that had been running for geological ages, experiments that were producing predators of almost unimaginable capability and sophistication. We lost not just the creatures themselves, but all the potential future adaptations that could have developed from millions more years of evolutionary refinement. And this brings us to a really profound question. What would these predators have become if they'd had more time to evolve? The creatures we've discussed were already at the absolute limits of what seemed physically possible for biological organisms. But evolution has a way of finding solutions to problems that seem insurmountable, pushing the boundaries of what life can achieve in ways that constantly surprise even the most knowledgeable scientists. Given enough time, could these predators have developed capabilities that we consider almost supernatural? Enhanced intelligence that approached human-level problem-solving? Sensory abilities that could detect prey through methods we haven't even discovered yet? Hunting strategies so sophisticated that they'd make modern military tactics look primitive by comparison? The fossil record gives us glimpses of creatures that were already pushing the boundaries of biological possibility. Predators with bite forces that exceeded the limits of what bone and muscle should theoretically be able to produce. Flying creatures that achieved aerial maneuverability that challenges our understanding of aerodynamics. Marine predators with hydrodynamic efficiency that modern submarine designers would envy. If these creatures had continued evolving for millions more years, they might have developed abilities that would seem like magic to creatures like us. The line between biological adaptation and what we'd consider advanced technology might have become completely blurred, producing predators that operated on principles we're only beginning to understand. But they didn't get that chance. And that's probably the most fortunate thing that ever happened to every other form of life on this planet. The extinction events that eliminated these apex predators created evolutionary space for thousands of other species to diversify, experiment, and eventually produce the incredible variety of life we see today. Without the constant pressure of avoiding predators that could kill almost anything instantly, prey species had the freedom to develop traits that weren't directly related to immediate survival. They could invest evolutionary energy in things like intelligence, social cooperation, tool use, and eventually the kinds of complex behaviors that led to civilization. The same evolutionary space that allowed humans to develop large brains and sophisticated cultures also allowed thousands of other species to explore ecological niches that would have been impossible in a world dominated by massive predators. The diversity of modern ecosystems is a direct result of the absence of creatures that once controlled every aspect of how life could exist on this planet. But understanding this history also gives us a sobering perspective on our current relationship with the natural world. We're living in ecosystems that are still recovering from the loss of their original apex predators, still adjusting to new patterns of predation and prey relationships that developed in the absence of the creatures that once defined how these systems operated. Modern conservation efforts are essentially trying to preserve and protect remnants of ecosystems that were fundamentally altered by extinction events that occurred thousands or millions of years ago. We're working with incomplete food webs, disrupted predator-prey relationships, and species interactions that developed in response to ecological pressures that no longer exist. This historical context changes how we think about current environmental challenges. When we see modern ecosystems struggling to maintain stability, we're often looking at systems that are operating without their original organizing principles. The apex predators that once maintained ecological balance through their hunting activities have been gone for so long that we've forgotten how important they were to ecosystem health. The reintroduction of wolves to certain areas has shown us just how dramatically the presence or absence of apex predators can affect entire ecosystems. Rivers change course, plant communities shift, and prey species alter their behavior patterns in response to predation pressure. If reintroducing a single predator species can cause such widespread changes, imagine the ecological impact of the massive predators we've been discussing. These prehistoric apex predators weren't just part of their ecosystems, they were the organizing force around which everything else evolved. Their hunting patterns determined where prey species could feed, their territorial requirements influenced migration routes, and their seasonal behaviors affected the timing of reproductive cycles throughout the entire food web. The loss of these creatures created a cascade of ecological changes that we're still seeing play out today. Species that evolved to avoid massive predators suddenly found themselves in environments where their anti-predator adaptations were no longer necessary. Energy that had been devoted to predator avoidance could be redirected toward other activities, leading to rapid evolutionary changes in behavior, physiology, and social organization. But it also created opportunities for smaller predators to expand into ecological roles that had previously been occupied by giants. Modern apex predators are essentially filling positions that were once held by creatures 2 or 3 times their size, which means they're probably working much harder to achieve the same level of ecosystem control that their prehistoric predecessors managed effortlessly. This has implications for how we understand predator-prey relationships in modern ecosystems. Current apex predators might be operating at or near their maximum capacity just to maintain basic ecosystem functions that were once handled by much larger and more powerful predators. Additional pressure from human activities, climate change, or habitat loss could push these already stretched predators past their breaking point much more quickly than we might expect. The vulnerability of modern ecosystems might be directly related to the fact that they're being maintained by predators that are essentially understaffed for the job they're trying to do. Without the massive predators that once controlled these systems, everything else has to work harder to maintain the same level of ecological stability. And this brings us to one of the most important lessons we can learn from studying extinct predators: the incredible importance of apex predators to ecosystem health. These weren't just random monsters that happened to be good at killing things. They were keystone species whose presence or absence could determine the structure and function of entire biological communities. The extinction of these creatures didn't just remove individual species from the environment. It dismantled ecological relationships that had been refined over millions of years. Predator-prey dynamics, competitive interactions, and resource distribution patterns all had to reorganize in response to the sudden absence of the creatures that had been controlling these systems since before most modern species even existed. Understanding this history helps explain why modern conservation efforts often face unexpected challenges. We're trying to preserve ecosystems that are operating without their original organizing principles, using management strategies based on observations of systems that have already been fundamentally altered by prehistoric extinction events. It also helps explain why some conservation successes have had such dramatic and far-reaching effects. When we successfully protect or reintroduce apex predators, we're not just saving individual species, we're restoring ecological functions that may have been missing for thousands of years. The effects ripple through entire ecosystems in ways that can be both surprising and profoundly beneficial. But perhaps most importantly, studying these extinct predators gives us perspective on the long-term trajectory of evolution and the temporary nature of any species' dominance. Every creature we've discussed was, at one time, the undisputed ruler of its environment. They had evolved to be perfectly adapted to their ecological niches. They had no natural enemies, and they seemed destined to dominate their respective domains indefinitely. Yet, they all disappeared, eliminated by changing environmental conditions, competition from new species, or various other factors that proved stronger than even the most successful predatory adaptations. The same evolutionary processes that created these magnificent killing machines also eventually led to their extinction, demonstrating that no species, no matter how successful, is immune to the forces of environmental change. This perspective is both humbling and inspiring. It reminds us that our current dominance of Earth's ecosystems is not a permanent achievement, but a temporary condition that requires constant adaptation to changing circumstances. Like every other species in the history of life, we're subject to evolutionary pressures that could eventually lead to our replacement by something better adapted to future environmental conditions. But it also shows us the incredible creativity and resilience of life itself. Despite multiple mass extinction events, dramatic climate changes, and countless other catastrophes, life has not only survived, but continued to produce new forms of amazing complexity and capability. The same processes that eliminated prehistoric monsters have also created every beautiful, fascinating, and remarkable organism we see around us today. The 24 creatures we've explored represent just a tiny sample of the incredible diversity of predators that evolution has produced over the billions of years of life on Earth. Each one tells a story about adaptation, survival, and the endless arms race between predators and prey that has driven the evolution of virtually every characteristic we see in modern organisms. Their extinction cleared the way for new experiments in predation, new approaches to survival, and eventually the evolution of intelligence sophisticated enough to study and appreciate the very creatures that once would have considered us nothing more than a quick snack. In a very real sense, we owe our existence to their absence and our ability to understand their biology to the evolutionary pressures they created during their time as Earth's dominant predators. So, as we conclude this journey through prehistoric terror, remember that these creatures are not just curiosities from the distant past. They're part of an ongoing story about life, adaptation, and survival that includes every organism alive today, including us. The same evolutionary forces that created them are still operating, still driving the development of new species and new approaches to the eternal challenges of finding food, avoiding danger, and successfully reproducing. The monsters may be gone, but the processes that created them continue to shape life in ways both subtle and profound. Understanding that continuity, recognizing our place in the same evolutionary story that produced these incredible predators, is perhaps the most valuable lesson we can take from our exploration of the creatures we should be very glad to know are extinct. The truth is, we've barely scratched the surface of what makes these extinctions so significant for human survival. Every single one of these creatures represents a world where stepping outside meant accepting that you might become someone else's dinner before you made it back home. But here's what really gets me about this whole situation. We spend so much time today worrying about relatively minor threats. A spider in the corner, a snake on a hiking trail, maybe a shark sighting that closes a beach for the afternoon. Meanwhile, our ancestors were dealing with predators that would consider a modern great white shark to be roughly equivalent to what we think of as a goldfish. The scale of difference is almost impossible to comprehend until you really dig into the numbers. When we talk about something like megalodon being 60 feet long, that's not just twice the size of a great white. That's a completely different category of ocean predator. We're talking about something that could bite a small boat in half and still have room for dessert. And that brings us to something most people never really consider about these extinct nightmares. They weren't operating in some alien environment that bears no resemblance to our world. Many of these creatures were living in places that look remarkably similar to areas where we vacation, work, and raise our families today. Take California, for instance. Seems like a pretty nice place to live, right? Beautiful beaches, pleasant climate, lots of outdoor recreation opportunities. But until about 11,000 years ago, you couldn't enjoy any of those amenities because the local wildlife included bears the size of small elephants that needed to kill something substantial every single day just to meet their caloric requirements. Florida's coastal waters are popular with tourists who want to experience marine life up close. But those same waters once hosted sharks with jaws large enough to swallow entire tour boats. The Caribbean islands that millions of people visit for relaxation and swimming were once patrolled by marine predators that would have made modern vacation planning completely impossible. Even the Great Plains of North America, which we now think of as peaceful agricultural regions, were once hunting grounds for flightless birds that could run down prey at highway speeds and crack skulls with single strikes from beaks designed like medieval weapons. The idea of crossing these areas on foot would have been essentially suicidal for anything smaller than a fully grown mammoth. This geographic overlap between prehistoric terra and modern comfort zones really drives home how much our world has changed. We're living in the same places where these creatures once dominated, but we've inherited a version of Earth that's been sanitized of its most dangerous inhabitants. The psychological impact of this realization can be pretty intense when you really think about it. Every peaceful nature walk you've ever taken, every camping trip, every day at the beach, all of these experiences were only possible because creatures like Arctotherium and Megalodon are no longer around to turn recreational activities into survival horror scenarios. But here's where things get really interesting from an evolutionary perspective. The extinction of these massive predators didn't just make human civilization possible, it fundamentally altered the selective pressures that shape how species evolve today. Modern predators are operating in a world where they don't have to compete with creatures that could eliminate them as easily as they eliminate their own prey. This has created what scientists call ecological release, where species that were once constrained by the presence of superior competitors suddenly have access to resources and opportunities that were previously unavailable. It's like removing the professional athletes from a recreational sports league. Suddenly, everyone else gets a chance to compete at levels that would have been impossible before. The effects of this ecological release are still playing out in ecosystems around the world. Modern apex predators are essentially operating in environments that were designed for much larger and more powerful creatures. They're trying to fill ecological roles that were once occupied by predators 2 or 3 times their size, which means they have to work much harder to achieve the same level of ecosystem control. Think about it this way. A modern grizzly bear is certainly an impressive predator, but it's trying to do the job that was once handled by Arctotherium. That's like asking a pickup truck to do the work of an 18-wheeler. It can handle some of the same tasks, but not with the same efficiency or capacity. This has created modern ecosystems that are probably more fragile than they appear. When your apex predators are already working at maximum capacity just to maintain basic ecological functions, any additional stress from human activities, climate change, or habitat loss can push the entire system past its breaking point much more quickly than anyone expects. We've seen examples of this ecological fragility in areas where apex predators have been removed by human activities. Without sufficient predation pressure, prey populations can explode beyond the carrying capacity of their environment, leading to habitat degradation that affects every other species in the ecosystem. It's like removing the keystone from an arch. Everything else becomes unstable once that crucial element is gone. But the absence of prehistoric megapredators has also created opportunities for smaller, more adaptable species to diversify in ways that would have been impossible in a world dominated by giants. The incredible variety of life we see today is partly a result of evolutionary experimentation that became possible only after the largest predators disappeared from the scene. This diversification process is still ongoing, and it's being accelerated by human activities that are creating new types of environments and selective pressures. Urban ecosystems, agricultural landscapes, and other human-modified habitats are essentially evolutionary laboratories where species are adapting to conditions that have never existed before in Earth's history. Some of these adaptations are producing predators that are specifically designed to exploit human-created environments. Urban coyotes, suburban mountain lions, and city-dwelling raptors are already showing behavioral changes that could be the first steps toward the evolution of predators that specialize in hunting in human-dominated landscapes. The really unsettling possibility is that we might be inadvertently creating the selective pressures that could eventually produce predators specifically adapted to hunting humans. As we continue to modify ecosystems and create new types of environments, we might be setting up evolutionary experiments that could have outcomes we never intended. But let's step back from these speculative scenarios and focus on what we can learn from the creatures that actually existed. Each of the 24 species we've discussed represents a different solution to the fundamental challenge of being a successful predator. They show us the incredible variety of approaches that evolution has developed for the basic task of catching and eating other organisms. Some relied on overwhelming size and brute force, using their massive bulk to simply overpower anything they encountered. Others developed specialized hunting techniques that allowed them to take down prey much larger than themselves through precision and efficiency rather than raw power. Still, others evolved sensory capabilities that gave them such tremendous advantages in detecting and tracking prey that escape became virtually impossible. The diversity of these approaches tells us something profound about the creative potential of evolutionary processes. When environmental conditions favor the development of efficient predators, evolution doesn't just produce bigger versions of existing designs. It experiments with completely new approaches to predation that can be both ingenious and terrifying. The buzz sawmouth of Helicoprion, the spiral teeth arrangement that baffled scientists for decades, represents one of these evolutionary experiments. Instead of simply making shark teeth bigger or sharper, evolution tried something completely different. A feeding mechanism that looked more like industrial machinery than biological adaptation. The shovel jaw of Platybelodon shows us another type of evolutionary creativity, rather than developing bigger tusks or stronger bite forces like other proboscideans. This species evolved a completely unique feeding apparatus that could process plant material with mechanical efficiency that modern agricultural equipment would envy. These examples remind us that evolution is not constrained by our assumptions about what predators should look like or how they should function. When selective pressures favor novel solutions to predatory challenges, evolution can produce results that seem almost alien in their creativity and effectiveness. This evolutionary creativity extends beyond individual species to entire ecosystems. The prehistoric world supported predator guilds, groups of different predator species that divided up hunting niches in ways that allowed multiple apex predators to coexist in the same environment. Modern ecosystems rarely support this level of predator diversity, partly because there isn't enough prey biomass to sustain multiple species of truly large predators. The loss of these complex predator communities represents one of the most significant ecological changes in Earth's recent history. We went from ecosystems where predation was dominated by multiple species of giants, working different hunting strategies, to systems where a single apex predator species might be responsible for controlling prey populations across vast areas. This simplification of predator communities has made modern ecosystems more vulnerable to disruption. When you have multiple predator species sharing the work of controlling prey populations, the loss of one species can be compensated for by the others. But when you have just one apex predator doing all the work, its disappearance can cause ecosystem-wide collapse. The reintroduction of wolves to Yellowstone demonstrated this principle in action. The return of a single predator species caused cascading changes throughout the entire ecosystem, affecting everything from river patterns to plant communities to the behavior of other wildlife species. If the presence of one relatively small predator can cause such dramatic changes, imagine the ecological impact of the massive predators we've been discussing. These prehistoric giants weren't just individual species occupying specific ecological niches. They were ecosystem engineers whose presence or absence could determine the structure and function of entire biological communities. Their hunting activities influenced migration patterns. Their territorial requirements affected habitat use by other species, and their seasonal behaviors synchronized reproductive cycles throughout the food web. The extinction of these creatures didn't just remove individual species from their environments. It dismantled ecological relationships that had been refined over millions of years. Prey species that had evolved elaborate anti-predator strategies suddenly found themselves in environments where those adaptations were no longer necessary. Habitat use patterns that had been shaped by predation pressure could reorganize around new priorities like resource competition and reproductive success. This ecological reorganization is still ongoing in many ecosystems around the world. We're essentially watching the long-term consequences of extinction events that occurred thousands or millions of years ago, as species continue to adapt to the absence of the predators that once controlled their evolutionary development. Understanding this historical context changes how we think about current conservation challenges. When we see modern ecosystems struggling to maintain stability, we're often looking at systems that are still adjusting to the loss of their original organizing principles. The predators that once maintained ecological balance through their hunting activities have been gone for so long that we've forgotten how important they were to ecosystem health. This perspective also helps explain why some modern conservation efforts have had such dramatic and far-reaching effects. When we successfully protect or restore apex predator populations, we're not just saving individual species. We're restoring ecological functions that may have been missing for thousands of years. The effects ripple through entire ecosystems in ways that can be both surprising and profoundly beneficial. But perhaps the most important lesson we can learn from these extinct predators is the temporary nature of any species' dominance. Every creature we've discussed was once perfectly adapted to its environment, with no natural enemies and seemingly unlimited potential for continued success. Yet they all disappeared, overcome by changing conditions that proved stronger than even the most sophisticated predatory adaptations. This historical perspective is both humbling and inspiring. It reminds us that our current dominance of Earth's ecosystems is not a permanent achievement, but a temporary condition that requires constant adaptation to changing circumstances. Like every other species in the history of life, we're subject to evolutionary pressures that could eventually lead to our replacement by organisms better adapted to future environmental conditions. But it also demonstrates the incredible resilience and creativity of life itself. Despite multiple mass extinction events, dramatic climate changes, and countless other catastrophes, evolution has continued to produce new forms of amazing complexity and capability. The same processes that eliminated prehistoric monsters have also created every beautiful, fascinating, and remarkable organism we see around us today. The 24 creatures we've explored represent just a tiny fraction of the incredible diversity of predators that evolution has produced over billions of years of life on Earth. Each one tells a story about adaptation, survival, and the endless arms race between predators and prey that has driven the evolution of virtually every characteristic we see in modern organisms. Their extinction cleared the way for new experiments in predation, new approaches to survival, and eventually the evolution of intelligence sophisticated enough to study and appreciate the very creatures that once would have considered us nothing more than a convenient snack. In a very real sense, we owe our existence to their absence and our ability to understand their biology to the evolutionary pressures they created during their reign as Earth's dominant predators. So, as we conclude this exploration of prehistoric terror. Remember that these creatures are not just curiosities from the distant past. They are part of an ongoing story about life, adaptation, and survival that includes every organism alive today, including us. The same evolutionary forces that created them are still operating, still driving the development of new species and new approaches to the eternal challenges of finding food, avoiding danger, and successfully reproducing. The monsters may be gone, but the processes that created them continue to shape life in ways both subtle and profound. Understanding that continuity, recognizing our place in the same evolutionary story that produced these incredible predators, is perhaps the most valuable insight we can gain from our journey through the gallery of creatures we should be very, very glad to know are extinct. And that's a wrap on our countdown of 24 deadly animals that no longer share our planet. From massive marine predators that turned ancient oceans into hunting grounds to terrestrial giants that made land travel a deadly gamble, we've explored creatures that redefined what it means to be a successful predator in Earth's long history. Each of these species dominated their respective environments for millions of years, proving that their terrifying designs weren't evolutionary accidents, but successful strategies for survival in worlds that were fundamentally different from the one we inhabit today. Their extinction created the evolutionary space necessary for smaller, more adaptable species to diversify and eventually create the rich ecosystems we see around us. The next time you're enjoying a peaceful moment in nature, whether it's a quiet walk through the woods, a relaxing day at the beach, or simply sitting in your backyard watching birds, take a moment to appreciate just how different that experience would be if any of these prehistoric nightmares were still around. The tranquility we take for granted is actually